In the previous video, we covered the orthorhombic crystal system and the relationship between crystal systems. The orthorhombic crystal system is defined by a unit cell with 3 different side lengths, but all angles 90 degrees. The first of the 3 orthorhombic point groups is called 2, 2, 2. This represents the 3 perpendicular two-fold rotation axes that make up this point group. This dashed line is an edge behind the object. In this simulation of that shape, you can see how it's like a squashed tetrahedron. Here is a two-fold rotation axis. Here is a hypothetical 2, 2, 2 crystal. Take note that there are no rotation or reflection symmetries other than this two-fold rotation axis, this one, and this one. The mm2 point group has a two-fold rotation axis and 2 mirror planes that are perpendicular to each other but parallel to the axis. This diagram shows the orientation of the mirror planes and rotation axis using a water molecule, H2O, as the example object. This is the shape in the diagram. Here is one of the mirror planes, and here's the other one. And then looking down on the crystal from the top, along the two-fold rotation axis, we can clearly see its corresponding symmetry, as well as both of the intersecting mirror planes. Hemimorphite is the most common mineral in this group, and this is a simulation of an ideal double-terminated hemimorphite crystal. Here's the first mirror plane, the second mirror plane, and the rotation axis, with the intersecting mirror planes. By convention, the crystallographic axes are aligned such that the C-axis is parallel with the rotation axis. Here is a hemimorphite crystal cluster from the Ojuela mine in Mexico. The third and final point group in the orthorhombic system is the MMM point group. Each M is an abbreviation for 2/m, so this point group is made up of 3 sets of two-fold rotation axes with perpendicular mirror planes, totaling 3 axes and 3 planes. Here is a simulation of the shape. Here we see 2 intersecting mirror planes and a two-fold rotation axis, another set of mirror planes and a rotation axis, and finally, along the C direction, another pair of intersecting planes and rotation axis. Keep in mind that although we see a pair of planes when looking down each of the 3 crystallographic axes, there are only 3 mirror planes in total. Danburite is an MMM mineral, and this is a simulation of a danburite crystal. Here are 2 mirror planes and a rotation axis, and from another direction, and from the third direction. And here is an actual danburite crystal. In the next video, we'll talk about the rhombohedral crystal system and its relationship to the cubic system.